Okay, good morning, one and all. This is the first seminar in the core seminar series of Ad Hoc Sensor Network Elective 4 for final year semester 2020-21. So, in this Ad Hoc Wireless, Ad Hoc and Sensor Network, we have 28 students. So, we have divided them among 14 different groups. And PDF paper has been found after literature survey by all the students. So students selected a paper and they are going to give a presentation on that. So two students have been kept per group. So today is 19th of December 2020. Suvarna and Alisha, they are going to give the first presentation in this series. 13 more presentations will be followed and it will be completed within coming 1 week. So I now invite our student Alisha from Division A and Suvarna from Division C to give the first presentation in this series. So they are going to talk on prevention of cooperative black hole attack in wireless ad hoc networks. So please, Alisha and Suvarna, start your presentation. Thank you. Yes, you may start, please.
Okay, sir. So, as sir has given the introduction already, so today we are going to give a presentation on prevention of cooperative black hole attacks in wireless ad hoc network. So, to begin with, as we all know that nodes in wireless network are mobile in nature, and which makes them vulnerable to various security attacks. And one of the security attack could be black hole attack. So, today we will see what does black hole attack mean, why is it necessary to prevent those attacks, and also the methodology to do the same. So with this brief introduction about our session, I will hand over this to my friend and she will explain further. So over to you, Suvarna.
Okay. Good morning, everyone.
Good
I'm
morning.
Suvarna. Outline of presentation, motivation scope, objective literature survey, methodology, and data routing information table, wireless sensor nodes, simulation and results. Motivation, the dynamic topology of manners allows nodes to join and leave the network at any point of the time. This generating characters of mobile network as a rendered is it valuable to secret attacks. A black hole is a node that always responds positively with the response request message to every response request, even though it does not really have a valid route to the destination node. Below the list is some of the multidimensional negative effects of the cooperative black hole that causes adverse effect on the wireless ADHOC networks. First, the node explodes AOD adversed itself having a valid route to a destination node, even though the route is a spurious with the intention of intercepting packets. Second, the node consumes interpreted packets. Hence, it is a very request to design technique to identify multiple black holes, cooperative with each other, and solution to discover a safe route avoiding cooperative black hole attacks. The second one is scope. With the help of the proposed solution, most secure routing path can be determined by source node. It achieves higher packet delivery and correction detection probability. As long as the attack is identified, the control message coming from it can be ignored. Objectives to the project to the proposed methodologies for identify the multiple black hole nodes cooperating in as a group with the help of the with a slightly modified AOD protocol by introducing data routing information table and cross checking. Literature survey, paper name and method user and limitations. Mechanism for detection of cooperative black hole attack in mobile ADHOC networks by JNS Colley and Akil. Identify the multiple black hole nodes cooperate as group by introducing data routing information table and cross checking. Packet delivery is ratio increased by 17%, but performance is decreased. Prevention of cooperative black hole attack in mobile network, Tamilishin and Sankar Anand. Prevention of cooperative black hole attack by using a fidelity table. Packet delivery ratio increases, but delay loss is increased. Routing security is wireless ADHOC networks. Modified response request and routing response only detect the black hole attack, but the cooperative black hole attack. Methodology, the data routing information table, the solution to avoid the cooperative black hole attack, and solution to identify the multiple black hole nodes in the one time check. The solution to identify the multiple black hole nodes acting in a cooperation involves two bits of additional information from the nodes responding to response request of the source node S. Each node maintained as the additional data routing information table. Data routing information table, additional table of the data routing and routed to the nodes maintained by node 4. In DRA table, 1 stands for true, but 0 stands for false. The first bit from stands for information and routing data packet from the node, while second bit through the stands for information and routing data packet through the node in the node field. In the reference to the example figure 3, sample of the database maintained by node 4 in the shown in table 1. The entry of the 10 for node 3 employs node 4 as the routed data packets from the 3, but as they are not routed any data packets through the 3. Before node 3 moved away from the 4. The entry 1 for node 6 employs node 4 successfully routed data packets from the through node 6. The entry 0 for node B2 employs the node 4 as a not routed any data packets from R0 B3 B2. Data routing information table. It explains modified AOD protocol and algorithm to prevent cooperative black hole attacks. In our technique, we are rely on reliable nodes through the which the source node has a routed data to transfer data packets. The modified AOD protocol, the algorithm for the proposed methodologies are illustrated in figure 5. In the protocol, the source node broadcasts and response frequency message to the discover to second route to the destination node. The intermediate node generating the response request key as to prevent next off node, and it is a DRA entry of the next off node. Upon receiving response request message from the intermediate node, source node will be checked it in over DRE table to see whether intermediate node is reliable node, or if the source node has the intermediate node before the route node, then intermediate node is the reliable node and source node starts routing the data through intermediate node. Otherwise, intermediate node is unreliable and source node sends further request message to the next of node to check the identify of the intermediate node and ask next of node if intermediate node has the routed data packets through a next of node, who is the current next of node next of to destination, and as the current next of node routed through is to say through next of. In the next up node is turns response with the further request messages, including DRA entry for intermediate node and next up node of the current next up node, and DRE entry for the current next up node.
So to further continue with this algorithm, based on the further request message from next hop node, source node checks whether the next hop node is reliable node or not. And if the node has routed data through the next hop node before, then the next hop node is reliable, or else it is unreliable. And if the next hop node is reliable, source node will check whether the intermediate node is black hole or not. And if the second bit of the data routing information entry from the intermediate node is equal to 1, and the first bit of the data routing information entry from the next hop node is equal to 0, then the intermediate node is black hole. And if the intermediate node is not a black hole and the next hop node is reliable node, the route is secure, and the source node will update the data routing information entry from for intermediate node with 0, 1, and starts routing the data packets via that intermediate node. And if the intermediate node is black hole, the source will identify all the nodes along the reverse path in the intermediate node to the node that generates the route response and as a black hole. And the source node will ignores all the route responses from that black hole and broadcast the list of cooperative black holes. So if we consider this algorithm, and to explain this algorithm is with a particular figure, we will consider this network
Alisha, I have a
topology.
question.
And
Can you first
yes, sir.
define what is black hole?
So as we have already given the definition of what does black hole mean, but I will explain it again. So black hole is something. Is that okay? Black hole is node that always responds positively with route response message to every route request message, even though that does not really have any valid route to the destination node.
Can you explain?
Sorry, sir.
Go back. Can you explain? Or even if it's okay if you don't go back, can you just tell me in your words what is meant by black hole?
So actually, black hole is not a reliable node in the network topology. So here is we have source node, and source node has to send the data packets to the destination node D. So black
Correct.
hole is the node that that actually says the source node that it is the reliable node and it can transfer the data to the destination node without any data loss. But the situation is that it actually consumes that data packet and does not allow that data packet to reach the destination node.
Okay, so it accepts the work, but it cannot execute the work.
Yes, sir.
Is it right? Hello?
Hello? Sorry, sir.
It
Yes, sir.
accepts the work, it accepts the work, but it cannot execute the work. So that is a black hole, right?
Yes, sir. Yes, sir.
Okay, so it doesn't know whether it will be able to take the packet from the source to the destination or not. It does not have any idea, but it just says yes to the work. But after it receives the packet from the sender node, the data is lost in the black hole node. So this is the definition of black hole, right?
Yes, sir. Yes,
Okay.
sir.
Okay, you carry on with your presentation. Thank you.
Okay, sir. So if we take this network, here node B1 responds to the source node with route response message, and it provides its next hop node B2 and the data routing information for the next hop. And here the black hole node lies about using the path by replying with the data routing value equal to 0, 1. And upon receiving the route response message from B1, the source node will check that whether it will check in its own DRI table to see whether B1 is reliable node or not. And since yes has never sent any data through B1 before, so B1 is not a reliable node to yes. And then the yes sends the further request to the B2 via the alternative path. And that alternative path is nothing but S to 2 and 2 to 4 and then B2. And it asks B2 that B2 has routed any data from B1, and that B1 is nothing but who is B2's uh, next. And if the B2 has routed data packets through B2's next hop, then since B2 is collaborating with B1, it replies positively to all the three requests. So when that source node contacts with node 6 via alternative path, that is S2, 2, 2 to 4 and 4 to 6, to check the claims of node B2, as B2 is saying that B1 is a reliable node, but it will check with the other path also, that is S2, 2, 2 to 4 and 4 to 6, and the node 6 will respond negatively. And since node 6 has neither a route to node B, node B2, nor has received any packets from B2, the data routing table, the value from data routing information corresponding to B2 is equal to 0, 0. And based on the information, node yes can infer that B2 is a black hole, and
Yeah.
if node B1 has supposed to have route, that is, if node B1 has supposed to have routed data packets through node B2, it should have validated the node before sending it. So now since B2 is invalidated through node 6, node B1 must be cooperating with node B2, and hence both the nodes B1 and B2 are
A
marked
black
as
hole.
black holes,
Okay.
black hole
Okay.
nodes.
Very
And
good.
this information
Understood.
is propagated through the network, leading to their listing as a black holes.
So after that, no
And
other.
further also the yes discards any further responses. Yes, sir.
So no other nodes will be
Sorry, sir,
transferring any
I can't
information.
hear you.
So no other nodes will be transferring any information through B1 or B2 in future, right?
Yes, sir. As they have recognized as black hole, the yes will automatically recognize them, and it will never send any data package through those nodes.
S
And it
is
will
not sending data
automatically
packet.
discard all the route response messages that are being fed from B1 and B2 to yes node.
So this is actually called as a route updation in the whole topology. So B1 and B2 are black holes. This thing is found out by S collaborating with 2, 4, and
Huh.
6. And after S finds out that B1 and B2 both are black holes, that data is updated in the network topology table. And in future 246S1, no node will be transferring any data through B1 and B2. So this is called as table updation.
Okay, okay,
That
sir.
is good. Good. You can go to the next slide, 5.3.
Okay, sir. So next is the simulation and the results of the experiments. So the experiments is carried out using the network simulator NS2 and 802.11 MAC layer implementation in NS2. And the performances of three protocols are evaluated. And those three protocols are standard AODV protocol, that is the ad hoc on demand dis- then AODV with two malicious nodes cooperating in black hole attack. Then AODV with proposed algorithm. And the parameters that
So
are considered are
what is
nothing
the
but mobility of the nodes.
full form of AODV? Ad hoc on demand.
Uh, Ad hoc on demand. Uh, it is vector routing, but I don't know what does do you mean.
Yeah, ad hoc on demand vector routing protocol. So all this, whenever you are putting some abbreviation in a slide in PPTs, first you should mention what is the full form of that, and you should explain that part first, and then you can use that
Yes,
abbreviation thoroughly. So this is a message to all. Directly from the first slide itself, do not
yes, sir.
start using abbreviation. Once at least in the paper, if you write, if you do a presentation, at least once initially you should explain what is it and what is the full form, and later on you can start using the abbreviation. Okay, proceed.
Yes, sir. So next we have the results of the simulation that we have got. So in figure 5, the metric packet delivery ratio is plotted against the number of active connections. And as the total number of mobile nodes are 30, the number of connections will be 29. So that is from 0 to 29 connections. And a general observation is that AODB achieves maximum delivery ratio with 10 to 25 active connectors. That is from this 10 to 25. And the delivery of that the and then the delivery ratio falls when the maximum number of connections are established. That is when the connections are more than 25. That is from 25 to 29. The delivery ratio will decrease
Okay.
slightly. So in figure 6, the packet delivery ratio is plotted against the mobility of the nodes. And it is observed that the performance of network reduces when the AODV is under constraint. cooperative black hole attack, and when the mobility of node in the network increases. So, which results into frequent route response generations, and which gives the opportunity to malicious nodes to send more false route response packets. So, this is what we can conclude from figure 6. And then we have figure 7. It shows the false positive rates. So false positive is nothing but actually the black hole is saying that it has the route to the destination node, but in real scenario it doesn't have any valid path to destination node. So this is what false positive means. And the false positive ratio versus the mobility of the nodes for different percentage of black hole nodes. So the maximum value of observed false positive rate is found to be at 7%. And then in figure 8, it shows that how data packets delivery ratio varies with respect to the number of black hole nodes. And it is observed that even when the 20% of nodes in the network are malicious black holes, the percentage of packet successfully delivered is more than 90%. And then after this, we will come to the conclusion. So we can conclude that the proposed solution can be applied to identify multiple black hole nodes, copy path from source to destination by avoiding multiple black hole nodes acting acting in cooperation. And as a future work, the proposed security mechanism may be extended so that can depend against other attacks like security resource consumption attack, then packet dropping attack, and gray hole attack, etc. So these are the references that we consider while doing this research. And with this, we will come to the session end of the session. So thank you.
Can I ask you a question?
Yes, sir.
What do you think is the cause of generation of black hole? How a black hole node is created actually? What it does, we know. It eats up all the data, but why?
Sir, I did entire survey on how we can prevent
No,
that.
how it eats up all the data, because whenever we are designing a node, we are not designing a black hole node, so somehow it turns into a black hole node. Okay, so why does it turn into black hole node? Why it eats up all the packet? So what is the cause of generation of black hole node? That is my question. So can you find it out and send me a document? Question is understood?
Sir, I don't have.
How a
Yes, sir.
very
Yes, sir.
simple routing node turns into a black hole node?
Yes, sir. Yes.
What happens in hardware, or maybe software? Exactly what is the kind of a
Yes, I
change
will do
that
that. I
takes
can send
place
the
in the
document.
node, so that a very simply designed, a very effective routing node becomes a black hole node, that it accepts all the uh, work, but it does not execute any of the work, and it eats up all the packets. And not only it does it for itself, but you have seen in your diagram, B1 and B2 both are black hole nodes, and kind of B1 is helping
Okay.
B2 to eat up all the packet.
Yes.
So there is some special thing going on between B1 and B2, that B1 is helping B2 becoming a black hole node. So what is the
Yes, sir.
background between these two? So whatever paper you are having,
Okay.
whatever 3 references you have given, what you do is try to find the cross references. All the papers you are having, you'll be finding there are references at the end of it, at the end of the main
Yes.
paper. In those paper you search,
Yes.
and you just find out that what is the cause of creation of a black hole. So today only you search it out. You can copy from some paper, and from whichever paper you are copying or whichever website you are copying, please mention that in your document and put name of you two, because you two are there in the group, and send it to me, email it to me.
Okay, sir.
Okay.
Yes, sir.
Yes, sir.
Anybody else is having any question? Okay. If not, then we
Yes,
can conclude this session. Thank you. And other sessions also we will I will schedule, and mostly tomorrow. Yashoda, can you present tomorrow?
Sir, I will discuss
Okay,
with
and
my
don't
group
read
members,
from
sir.
slide as Suvarna did. This is a not a good practice.
Okay, sir.
Don't read from slide. And Alisha, also you try to explain things. So you can keep the slide in front of your eyes, but you should not read from slide line by line. That is a very bad practice. So you try to explain the
yes,
thing
sir.
in your own words. Try to read the you can read the line once, but try to explain the thing in your own word, and don't hurry. Don't try to finish the presentation as soon as possible. You are having all time in the whole world, so every line you can explain. You can put less number of lines in the slide. Your slide is very good, what you have prepared, this much is enough, but you try to explain every line in your own way. And Suvarna, it is not a very good technical presentation that you had given. You have simply read from all the slides. That is not you should do. And don't say objective, and this is the line, don't say methodology. That word you are not supposed to say like that. You should change the slide, and automatically you should put that word uh, in your presentation. Like I'll just tell you, suppose you are going from uh, result to the references. So what we will say, I'll tell you. So this was the all result we have seen for the whole work. So after the result, we will go in the next section, that is the references section, and we will see what all papers we have referred in that. So you say this, create a small introduction, and then you just shift to the reference slide. So don't be very strict like this. Objective, this is the line. Methodology, this is the line. No, that is not the way of a transition from one slide to another slide. Anyways, so this was your first presentation. You just keep on attending others presentations, so you will know how to present. Technicalities, because everybody's work is different, and you try to understand as much possible from everybody's work. So this was a good first session, and thanks to Alisha and Suvarna that you took the courage to be the opening batsman or batting moment. That was a very big thing. So I congratulate your things are done post seminar. So whenever it is next course seminar, you'll be notified, and please join. Thank you. You can leave